Skyscrapers are setting new height records, enormous tunnels are opening up new transportation routes, and gigantic bridges are covering greater distances than ever. In addition, huge engineering and infrastructural projects are either just getting started or nearly finished all around the world. Megaprojects aren't called that for nothing. When they say huge, they really mean big. So to identify the most astounding dams, structures, and large machinery on Earth, we looked at some of the most spectacular megaprojects from the past and present. Today, we will explore 5 of the most amazing underwater megaprojects from across the world that will blow your mind. Number 5. Port Mann Bridge, Vancouver, BC. Time to build is 6 years and cost to build is $1.93 billion. The bridge east of Vancouver, British Columbia, opened in 2012 and remained the second longest bridge in North America, despite being the widest bridge in the world, until the Bay Bridge's east span just opened. The amazing 288 cables the cable stay bridge uses enable it to span 6,866 feet in total. Transportation and Infrastructure Ministry of British Columbia/Flickr. There is a great deal of traffic on the Port Mann Bridge, and it was determined that more lanes were required. Initially, a preservation proposal was created that would have added a second bridge to create a pair of one-way spans, conserving the present span's aesthetic value and historical significance. But this notion was dropped. Why maintain a historic bridge when it can be demolished and the neighborhood would lose a beautiful landmark? It was decided to simply invest enormous sums of money to create one entirely new bridge and then demolish the historic bridge as a result, which led to the creation of the current project. 2 approaches around the main bridge, Surrey to the south and Coquitlam to the north. A 720-ton self-launching gantry assembled the 1,158 segments that made up the combined north and south approaches. Each segment weighed 80 tons. A new bridge was built to help relieve traffic congestion on the old bridge and shorten travel times. The bridge is a component of the province's bigger Gateway program, which was formed by the province of British Columbia to solve the city of Metro Vancouver's escalating traffic problems. The project's funding will come from tolls collected at the new bridge. Number 4. Chuo Shinkansen, Japan. Work on a Japanese maglev route that will link Tokyo to Nagoya by 2027. Osaka began in 2014. The project is expected to cost well into the double-digit billions, and it calls for trains between Tokyo and Nagoya to speed up to 314 mph, reducing travel time to only 40 minutes. The 178-mile line will primarily travel below and through tunnels as part of an unprecedented railroad project. This groundbreaking infrastructure project originated with a prototype. However, Japanese National Railways, which was determined to invest in high-speed rail, started experimenting with maglev technology as early as 1964. An 18.4-kilometer test track was built in Yamanashi Prefecture after the opening of the first Tokaido Shinkansen to test the novel natural levitation technology that enabled trains to travel at nearly 500 kilometers per hour. The Chuo Shinkansen will travel along a track that was extended by further 25 kilometers in 2013 as per the design. The new train speed was successfully tested along that same stretch, breaking the previous record for the fastest manned train in history. Number 3. Grand Renaissance Dam. By July 2017, the Grand Ethiopian Renaissance Dam project ought to be finished. The project, which will benefit not only Ethiopia but also Sudan and Egypt, is being funded by the citizens and government of Ethiopia. Despite the fact that Ethiopia accounts for 85% of the river's flow, the latter 2 nations rely on it for their water supply. The dispute over the GERD is a part of a protracted conflict over access to the waters of the Nile, which are viewed as a lifeline for millions of Egyptians and Sudanese citizens living in the downstream states of Egypt and Sudan, between Ethiopia and the upstream riparians on the one hand and the downstream states of Egypt and Sudan on the other. Despite the fierce disputes, Ethiopia continues to build the dam, claiming that the hydropower project will considerably enhance livelihoods in the area more generally. Although disputes over the distribution of Nile River resources have persisted for a long time, the conflict, particularly between Egypt and Ethiopia, significantly grew when Ethiopia started building the Blue Nile Dam in 2011. Ethiopia has long argued that it has the right to use its natural resources to address widespread poverty and raise the living standards of its people. More than 85% of the water that flows into the Nile River originates in Ethiopia's highlands. Egypt, which depends almost entirely on the Nile waters for domestic and commercial uses, sees the dam as a major threat to its ability to use the Nile for domestic and commercial purposes, despite Ethiopia's claims that the hydroelectric GERD will not significantly alter the flow of water into the Nile. Is it impossible to stop? No. The Blue Nile's rainy season, which started earlier this year and lasts through September, will naturally fill the reservoir behind the dam. According to Manchester University's Mohammed Bashir, who has been researching the GERD for the past 10 years, engineering-wise, physics-wise, there is no way to stop the filling currently until the water level hits the top of the dam wall. Number 2. Crown Sydney. Its distinctive contour and height make it the harbor's unmistakable focal point, and the building's design resembles three petals that are twisting and changing shape as it rises. The building site, which was previously home to a disused port and container storage facility, forced the employment of an inventive engineering solution that was less evident to the observer. The Robert Byrd Group's top-down jumpstart building style, a first for the edge of Sydney Harbour, resulted in significant program savings. The sophisticated sculptural design of Crown Sydney and its placement on a congested CBD site on the Barangaroo foreshore between Sydney Harbour to the west and another construction site to the west created various obstacles for Crown and their builder. The construction crew's main issue was handling the demands of operating at height in a high-wind environment like the Barangaroo foreshore and finishing the heavy lifting requirements in such a little area. A composite slab and beam structure makes up the main tower structure. A thorough analysis of footfall vibration was needed due to the large beam spans and thin slabs to ensure the building met code requirements and customer expectations, generating architectural ideas that strengthen rather than dismantle the current structure. A method that minimized beam penetrations and beam notches were developed after extensive coordination with a mechanical engineer. Analysis of differential shortening with megatruss, steel, concrete, and existing structural elements are taken into account. Mega column and mega pile designs were used to withstand the heavy concentrated truss loads. The 2,100mm diameter mega piles needed to withstand the truss loads had to be built, which required specialized piling rigs. Number 1. The International Thermonuclear Experimental Reactor. ITER, which is the Latin for the way, is an acronym for the International Thermonuclear Experimental Reactor. International Thermonuclear Experimental Reactor, or ITER, is a nuclear fusion power plant. ITER is a unique partnership of nations jointly responsible for constructing, operating, and decommissioning an experimental fusion facility. ITER being an experimental reactor, it will allow the study of fusion reactions which govern the Sun and other stars. Nuclear fusion will take place in the form of plasma in a tokamak. ITER project is experimental in nature, as the name suggests. It's a collaboration of 6 countries and 1 European Union. ITER is run, funded, and designed by 7 members. Since the initial conception of a global joint fusion experiment in 1985, thousands of engineers and scientists have worked on the design of ITER. In a 35-year partnership to construct and run the ITER experimental device, the ITER members, China, the European Union, India, Japan, Korea, Russia, and the United States, have advanced fusion to the point where a demonstration fusion reactor can be developed. What are your thoughts on these innovative underwater mega projects? Leave a comment and let us know. Thanks for watching and see you in the next video.